All right, A&P1 students, in this video we are going to talk about how our bones grow longer and how they grow wider. So we're going to first talk about how they grow longer, and I'm going to jump to our objectives here. So we are talking about the epiphyseal plate, because that's the location of our bones where we get the length, bone length, growth in the length, and then we'll talk about how our bones grow wider, so kind of what's going on when that happens to you. Okay, so things we have to remember is that after our bones are formed, there is always going to be two places where we're still going to have some of that hyaline cartilage, and that is going to be at the epiphyseal plate. So that's that little area or zone between the epiphysis and the diaphysis. So we have one at this end of the long bone, the proximal end, and one at the distal end. And then the other place that will always have cartilage is the articular cartilage, and so we'll always have a little bit of cartilage that covers the bone at the proximal end and also at the distal end. Okay, so we're going to focus in though on the cartilage that's at the epiphyseal plate. So that cartilage, under the influence of hormones, is going to continue to grow. So remember that it's the chondroblast. Those are the cartilage cells that are going to form cartilage. So when the cartilage cells or chondroblast are forming cartilage, they're forming cartilage on this side of this epiphyseal plate. So the side that's closest to the epiphysis. And then on this side, it would be they're producing cartilage on this side of the epiphyseal plate, so closer to the epiphysis. Okay, so that cartilage, under the influence of hormones, remember, the chondroblast will continue to form it. So you can imagine that as we get more cartilage formed here and also here, what that's going to do is like push this epiphysis, this distal one, and then this proximal one in this direction. So this one will be pushed this way, and this one will be pushed that way, because we keep producing more cartilage here, and it just keeps pushing this epiphysis away. So you can see how that's going to cause the bone to grow longer. Now that's not the whole story, because what's going to happen is we need the bone to grow, and so we got the cartilage growing. But what the osteoblast, remember those are the cells that form bone, what they're going to be doing is they're working at this end or this side of the epiphyseal plate. So they're here. So those are the osteoblasts working here and here. So what they're doing is they are converting this cartilage that's at this side of the epiphyseal plate, the side that's closer to the diaphysis, they're converting it to bone tissue. So then we'll continue to get this bone tissue kind of converting this cartilage, and so then you can imagine that if we convert this part here to bone tissue and then this part here, then we'll have a longer diaphysis. So that will cause, again, an increase in the length of our bone. And so that will continue to happen where pretty much the cartilage cells, the chondroblast, are working at about the same pace or speed as the osteoblasts that are working on this side. And then that'll just keep pushing the epiphyses away from each other. So this one in this direction and this one in that direction. And then also making the diaphysis longer, because we're getting bone formed from that cartilage. Bone's replacing the cartilage at this end and this end. So then it'll just continue to do that until we reach our late 20s. And then what happens is the osteoblast will eventually, under the influence of hormones, they're going to be faster than the chondroblast producing cartilage. And so eventually the osteoblast producing bone on this side will catch up with the chondroblasts that are producing cartilage on this side. And when they do that, then eventually all that cartilage that was at that epiphyseal plate will be converted to just bone. And then we'll start calling, and that's when long growth in our long bones stop, and then we reach our highest height. And so then we stop calling it a plate, because they call it closed, because it's now all bone and there's no more length and growth that can occur. So they call that the epiphyseal line because you can still see it on radiographs when you look at it. So it's just kind of that area that shows where the epiphyseal growth plate was at one time. And then you have it down here too. So that's how length in bone happens. It's all based on concentrated on that epiphyseal plate. And again, the chondroblasts are working on this side, making cartilage, and then the osteoblasts are on this side, replacing that cartilage with bone. And they'll continue to do that until the hormones change, and then the osteoblast will outpace the chondroblast, and all that cartilage at the epiphyseal plate will be converted to bone tissue. All right, so that is our description of growth in length. And they do call that interstitial growth. I usually, on the test, on my questions, I usually just say growth in length of long bones. So I don't have that term interstitial growth, but the book does use that term. Just realize I won't ask you to call it interstitial growth or ask you questions about it. As long as you know that it's the bone growing in length, you're good. Okay, so then the next thing that we'll talk about is the growth in width. So we know that our bones have to grow long, but they also have to get wider so that they can support our body as we're growing too. So they have to grow in width here. So we're going to talk about how they do that. And we have another picture. I think it's on the next page, sorry. Let me flip here. Yeah, and they call this type of growth where they grow wider, they call it appositional growth. But again, I won't ask you to identify it as appositional growth. I'll just say growth in width. Okay, so in this case, now we're not worried about length, growth of the bone in length, we're worried about the width. And so it would make sense if we want our bone to grow in width that we'd want to produce more bone along the sides. So like on the sides of our diaphysis. And so we do that. So like remember the periosteum? It's that outside layer that surrounds our bones. It has those osteoprogenitor cells in it that undergo mitosis and produce the osteoblast. So those osteoblasts that are located here, they will produce bone. That's what their job is. So they'll start forming bone. And so when they do that, so we get some bone forming here, then what you get is this thicker amount of bone and wider on the outside here. So what's working on the outside near the periosteum is osteoblasts. They're producing bone tissue. And that would make sense. Then the bone would get wider. So, but there's another part of this that you need to be aware of, is that we don't want we only need a certain amount of this bone on the compact bone that's on the outside of our bones. So if we have too much of it, our bones will be too heavy, and then our muscles wouldn't be able to lift our bones. So what we need to do is have on the inside here, remember that's the endosteum of a bone, that's that lining or membrane that lines the inside or medullary cavity of a bone. It also has those bone cells in it, osteoprogenitor cells and osteoblasts. So what's going on the inside in the endosteum, it's the other bone cells, the osteoclasts, that are working. And remember the osteoclasts, they break down bone or resorb it is the term. And so they need to resorb bone here on the inside, lining the medullary cavity, so that way we maintain a certain thickness of our compact bone. We don't want it to be real thick because, again, that's going to make our bones super heavy and our muscles wouldn't be able to lift them. So we have the osteoclast breaking down bone on the medullary side, so where the endosteum is, and then we have the osteoblasts working on the periosteal side on the outside, making bone. And so they both are, kind of paced the same, so they're working about the same speed. And then what that allows is for our bones to grow wider, but still maintain the right amount of thickness of compact bone, and then also, have that right size of medullary cavity too. So that's how our bones grow in width. So we don't have any like cartilage like we did with the long bone growth. We just have osteoblasts and osteoclasts working on either side. Osteoclasts working on the inside, inside the medullary cavity in the endosteum, and then the osteoblasts working just under the periosteum. And they allow for the bone to grow in width that way. So, all right. So that was our video on how our bones grow in width and length. So in the next video, we'll talk a little bit more about our bones and how we're going to kind of focus on remodeling. So like after they've grown in length and width, and we have our bones in our late 20s, then they continue to change throughout our lives. And so that's basically what we're going to talk about next, bone remodeling. I'll see you in the next video.